Place all planets between Earth and the Moon and see if they actually fit. Alright, let's line up every planet between Earth and the Moon to test this famous claim. Starting with Mercury, the smallest planet, followed by Venus, which is nearly identical to Earth in size but spinning backwards, and then Mars, the planet we might actually colonize. Now for the giants, beginning with Jupiter, which is so massive it has more mass than every other planet combined. You could line up 11 Earths across its width, and its great red spot alone is wider than Earth. After Jupiter comes Saturn, light enough to float in water if you had an ocean big enough. And finally, the ice giants Uranus and Neptune, both about 4 times Earth's width. The Moon at its farthest point is 397,000 kilometers away, while all the planets together still measure 388,000 kilometers. They fit with about 9,000 kilometers to spare. Enough room to add Pluto and still leave a gap. Now, let's run the simulation, but this time Jupiter's mass is doubled. Its gravity dominates immediately. Mercury and Mars are pulled in first. Within minutes, Venus follows. Over several hours, every other planet spiral inward. Everything collapses into a single gas giant, and neither Earth nor the Moon survives. What if the largest asteroid in the solar system hit Earth? This is Ceres, 940 kilometers wide. The asteroid that wiped out the dinosaurs just 10 kilometers. That means Ceres is nearly 100 times wider and thousands of times more massive. Now launch it at Earth at 25 kilometers per second. On impact, the energy released equals millions of dinosaur killer asteroids at once. Every nuclear weapon ever built? Not even a rounding error. Ceres doesn't leave a crater. It shatters the crust and punches into Earth's mantle. A molten impact basin forms over 4,000 kilometers wide. The shock is so powerful it changes Earth's rotation. Days could become hours longer or shorter. Trillions of tons of debris are blasted into space. Some escapes forever. The rest forms temporary rings around Earth. The entire planet becomes a global ocean of magma. Oceans boil away. The atmosphere is stripped. After millions of years, Earth cools, but life, as we know it, never returns. Travel forward in time and watch the solar system end. Alright, let's jump ahead about 5 billion years. The sun runs out of hydrogen in its core, fusion slows down, and the outer layers begin to expand. The sun becomes a red giant. Its radius grows large enough to consume Mercury. Venus is lost soon after. Earth is likely pulled in as well. Temperatures near the sun exceed several thousand degrees Celsius. The star becomes unstable. Its outer layers are pushed away into space at high speed. This forms a planetary nebula that lasts a few tens of thousands of years. At the center, only the core remains, a white dwarf, about the size of Earth, with roughly half the sun's original mass. Gravity weakens across the system. Surviving planets drift outward or escape entirely. Over trillions of years, the white dwarf cools. It no longer emits light. The sun becomes a black dwarf. The solar system ends as a cold, dark system with no active star. What if the closest star near our solar system went supernova? Alright, the nearest star to us besides the sun is Proxima Centauri, 4.24 light years away from our solar system. Proxima Centauri is a red dwarf with only 12% of the sun's mass, so it cannot naturally go supernova. However, let's explore this scenario hypothetically anyway. Boom! In a flash, Proxima Centauri goes supernova. The star releases about 10 to the power of 44 joules of energy. Nothing happens on Earth immediately. Radiation takes 4.24 years to arrive. Once it arrives, the night sky transforms with a brilliant new celestial object, absolutely stunning to witness, nearly as bright as the full moon, visible for several weeks. But stay calm. The shockwave never reaches the solar system, only radiation does. Cosmic rays and ultraviolet radiation increase as the debris passes through. Some ozone is damaged, raising surface radiation and cancer risk. Ecosystems are stressed but not destroyed. After decades, radiation levels return to normal. Because the star has only 12% of the sun's mass, Earth is not seriously harmed. Earth remains habitable and humanity survives. Crash 10 Earths and see if we could have super Earth that supports life. Alright, let's smash 10 Earths together and see. Boom! The collision throws huge amounts of hot dust and planetary debris into space. The planet becomes hotter and brighter than the sun. Surface temperatures rise to about 8,000 degrees Celsius. So, let's give it time to cool. After 50 years, the planet is still extremely hot. Temperatures stay above 900 degrees Celsius. The surface looks uneven. A long scar stretches across the planet. The atmosphere is thick and toxic. Surface pressure reaches 140 times that of Venus. Damn, that's bad. Nothing can survive yet. Okay, let's wait longer. After 1,500 years, the planet cools enough for liquid water. Oceans begin forming on the surface. The planet is now more than 3 times Earth's mass. Its radius is 37% larger, but after 10,000 years, the oceans disappear. Life is no longer possible. Do you know how small we really are? Let me show you in a proper way. Alright, let's line up the monsters of the universe. Starting with Earth. It takes 19 hours to fly halfway around it. But let's bring in Jupiter, the biggest planet in our solar system. If Earth were a grape, Jupiter would be a basketball. You could fit 1,300 Earths inside this gas giant. Suddenly, your massive home looks like a rounding error. But Jupiter is a joke compared to the boss. Here comes the Sun. It makes up 99.8% of all mass in our neighborhood. It is a burning ball of plasma so huge you could pack 1.3 million Earths inside it. It burns with the energy of billions of nuclear bombs every second. It seems like the absolute limit of size. But the universe is mocking us because we are just getting started. Meet Stephenson 2-18, the largest star ever found. It is a red supergiant so unreasonably massive that if you placed it in our solar system, its surface would extend past Saturn. It would swallow Earth, Mars, and Jupiter in a single gulp. If you flew a commercial jet around our sun, it would take months. But if you flew that same plane around Stephenson, the trip would take 1,200 years. This star is so big it breaks the laws of what our brains can comprehend. So take a good look at this absolute wall of fire and try to remember where Earth was. What happens if Betelgeuse went supernova right now? Look up at Orion's shoulder, that glowing red star that's Betelgeuse. Betelgeuse is a massive unstable star in Orion, basically destined to die. In an instant, boom, it explodes. The blast would shine brighter than every star in the sky. For weeks, maybe even months, Betelgeuse could outshine the full moon. Step outside at noon and you'd see it glowing like a second sun. But don't panic. At around 640 light years away, the deadly shockwave and radiation won't reach Earth. Instead, it would be one of the greatest cosmic shows in human history, an event no telescope or spacecraft could miss. As the explosion fades, this is how neutron stars are born. Insanely hot, incredibly bright, yet unbelievably small. What remains after? Betelgeuse's core could collapse into a dense neutron star, or if massive enough, form a brand new black hole. Around it, a massive nebula would bloom, painting Orion's shoulder with cosmic fire for thousands of years. And the best part? This could happen 100,000 years from now, or tonight. Every time you see Orion, remember you might be staring at a ticking time bomb of pure cosmic beauty.
Launch the smallest black hole straight toward Earth. All right, let's see what really happens. This is the tiniest confirmed black hole we've ever found. It weighs 3.8 times the mass of our Sun, compressed into a sphere just 11 kilometers wide. That's smaller than a city. Next to Earth, it's basically invisible. But size doesn't matter here. Only mass. As the black hole approaches, gravity starts tearing Earth apart. The atmosphere is ripped away first. Oceans lift off the surface, the planet stretches, then breaks. Earth is pulled into a thin stream of molten rock, falling straight into the black hole. No explosion, no struggle. In seconds, Earth is gone. Swallowed by something only 11 kilometers wide, the smallest black hole wins. Turns out you don't need to be big to end a planet.
Subscribe for more simulations like this. Comment which simulation you want to see next.